Hello, and welcome to the video portion for the third lab of ME123. Today, we are covering our first feature, the extrude. SolidWorks uses features to generate or modify 3D geometry. Extrude is the simplest of these features, though that doesn't mean that it's easy. In general, the extrude feature takes a sketch of a closed contour and pulls it through 3D space to produce a solid shape. Let's make our very first extrude. To start, I'm going to set my units to millimeters, and then from here, we can open up a new sketch on the top plane to get started. Next up, we can draw a center point rectangle by hitting the drop-down under the rectangle option and choosing center, and drawing in our shape. This is going to be centered on the origin, and we'll draw it out to about that size. Because it's always important to make sure that our sketches are fully defined, we're going to dimension this rectangle so that it is 60 units tall and 100 units wide. We can see that our sketch is fully defined based on the note down at the bottom of the screen. So to begin our feature, we can go back up to the Features tab and select Extruded Boss Base. Since we're still in our sketch, SolidWorks begins creating a new extrude using that sketch. Let's take a minute to look over the options that we have. Up at the top of the menu, we have a From option with a drop-down box. We're going to leave this one for later. Continuing down, we have Direction 1, which is currently set to Blind. A blind extrude just keeps going until it's gone the given distance, in this case 10 units. We can see that by modifying the distance, say to 40 units, changes the preview that we get in the graphics window. Cool, that looks about right. Let's hit our green checkbox, and we can finalize our extrude. On occasion while modeling, you may want to modify some of the geometry that you created previously. Similar to sketches, features can also be edited. You can do this by right-clicking the feature that you want to change and selecting the Edit Feature option up at the top left of the context menu. While we're editing, let's look at some of the other end conditions that we have. Instead of blind, we also have up to vertex, up to surface, offset from surface, up to body, and midplane. Let's see what midplane does for now, and we'll check out the others later. As we can see, midplane operates similar to blind, though with midplane it sets our extrude to straddle the plane that it's drawn on, so it goes half the distance up and half the distance down. Midplane is recommended if you're creating the first feature of your model with an extrude, as it often gives you more planes to use later on in the modeling process. This is especially useful when dealing with symmetrical objects, as it keeps the origin in the middle and keeps the plane centralized. Okay, so this looks pretty good. We'll hit the green checkbox once more, and we can continue on. So, now that we have some solid geometry, let's do a quick refresher on how to navigate in SolidWorks. We can zoom in and out by scrolling on the mouse wheel, and we can orbit our part by click-dragging with the mouse wheel. Finally, we can pan by holding the Control key on the keyboard and click-dragging on the mouse wheel. If we ever get lost, we can use the Zoom to Fit option up on the Graphics toolbar. In addition, we can return to our isometric view by hitting the drop-down option under View Orientation and selecting the isometric option from the drop-down here. If you're a hotkey person, Control 7 also brings you to the isometric view. Another neat hotkey is Control 8. This functions if you've got a surface selected or are within a sketch, and it moves you to be normal to the profile that you have selected. One thing to keep in mind while you're modeling is that your part should match the orientation of the part that's been given. I recommend frequently checking your own isometric view via the Control 7 trick to make sure that it matches the isometric of the given model. Okay, so we have our brick. Let's make it a little bit more interesting. I want to carve out a hole to make it lighter, perhaps some kind of slot that goes from this right surface over to the left one. A lot of the features that we cover in this class are going to have an inverse or a cut version. Extrude cut operates exactly the same as extrude, although it removes material instead of generating it. So, where should we make our sketch? We can create a new sketch on any one of the three primary planes by selecting them from the design tree, or we can create a new sketch on any flat surface of the model. Let's use this right face here. Once again, to create a new sketch, you can left-click to select the surface, right-click, and select the Sketch option from the context menu. To make our view a little bit easier, we can hit the Control 8 hotkey to snap us to the normal to perspective. So, now that we're here, let's draw our shape. I'm going to use the center point straight slot. This option lives under the Slot Sketch tool in the drop-down. Let's start our slot on the origin. We'll draw out the center line of the slot to be horizontal, and that looks about right. Now, to fully define our shape, first we want the construction line in the middle to be horizontal. We can see that that one's been automatically added. And then from here, we can use our Smart Dimension tool to set the radius of one of our arcs to 10 units. And then we can set the distance between the two arcs to be equal to 30. While we're here, let's look at some other ways to dimension between arcs. SolidWorks defaults to middle, but what if we want to dimension from extreme to extreme? Similar to how you can change a radius to a diameter, once you've created your dimension, we can clear our tools by hitting the Escape key, and then left-click on the leader of the dimension. Over here on the Properties toolbar, we can go to the Leaders option, and down at the bottom, we see that we have Arc Condition. Center to center is the one that we want to use, but we can also set this to max, or to min, or any variation. Center to center is the one that I want to use, so we'll leave those options set and hit our green checkbox before continuing on. So, now that our sketch is fully defined, how do we use it to cut through our first extrude? We can go back up to our Features tab, and this time select Extruded Cut. Now we have another question. How far along do we want to take our cut? Well, our brick is 100 units wide, so we can change our distance to 100 under the blind option, and that will make it so that our extrude goes all the way through. However, what if in the future we want our brick to be wider? If the sketch for the initial brick is edited, but this extrude isn't also modified, then the cut is only going to go partway through the object, which is going to violate design intent. In addition, typing in a 100 again is going to be reusing one of our dimensions, which also violates good design practice. Let's take a look at what other options we have under Direction 1. This top option, Through All, sounds promising. Let's give that a shot. As the name would imply, Through All is going to take the extrude and bring it through the entire object. If we hit our green checkbox here, we can see that the extrude is going to cut all the way through the brick. This option works great whenever you have a hole that goes through the entire model, as it doesn't use any dimensions and it makes for a model that responds well to being modified. If we go back into our extrude cut through the edit menu, we can see that there are also plenty of other options. Extrude and extrude cut share a majority of their starting and ending conditions, so I would recommend experimenting with each of the different options and combinations to see what each pairing can do. While we're here, let's check out another option, flip side to cut. If we select this checkbox and then hit our green checkbox once again, we can see the Extrude Cut feature now removes everything outside of the enclosed sketch. This can be a handy trick on occasion, but it's not what we want here, so we can undo our change and continue on. Now, let's add a cylindrical peg that goes up through the middle of our model. I'm going to start by opening up a new sketch on our bottom surface, and then from here we can draw in our circle. I'm going to center it on our origin, and then we're going to draw it out to have a diameter of 20 units. Now that our sketch is fully defined, we can go back up to our Features tab and select the Extruded Boss Base option and take a look at what SolidWorks is going to be doing. In this case, the extrude is going to be trying to go down instead of up. In order to fix this, we can hit the Reverse Direction option under Direction 1 to pop it into the correct orientation. We can see that the extrude is going to be overlapping with some of the geometry that we've already created. This is okay. SolidWorks does not double count material. However, leaving it as a blind extrude and trying to calculate what the dimension is going to have to be would violate good design practice, so let's take a look at some of our other options. Once again, we have Through All, which is going to do the same thing that it did last time. In this case, that ought to do the trick, but let's take a look at some of the other options first. Up to Surface and up to Vertex are going to continue the extrude until it has hit the selected surface or vertex, respectively. But there are some quirks to take note of here. You can select a surface or a vertex that doesn't intersect with our extrude. So if we have this set to up to vertex, we can also choose this vertex here. If you do, SolidWorks continues until the selected vertex lies on the plane created by the surface at the end of the extrude. Similarly, if you choose a surface that doesn't directly cross paths with the extrude, SolidWorks is going to extend the surface until it does. Offset surface is the one that I really want to cover for now, so let's select that and take a look at what our options are. As you could guess, we need to select a surface that we want the offset to be measured from, and then we can apply a distance that we want the extrude to go from that offset. In this case, let's type in a 50 here, and then we'll hit the reverse direction option to pop it so that it goes up to the surface and then 50 units further. Finally, we can hit our green checkbox, and we can see that SolidWorks generates the geometry, filling the peg through the brick. One thing to be careful of when making extrudes is to make sure that they merge properly. We can see in our design tree that we only have a single solid body. This tells us that there is only one distinct part in the model. However, if we were to go back into our extrude and uncheck the Merge Results box, we can see that we now have two solid bodies. One other hint that we have multiple solid bodies is that we have these graphical glitches where the cylinder emerges from our initial brick. For the purposes of this class, it's important to make sure that you only ever submit parts with one solid body. You can also get multiple solid bodies by having disconnected features, like these two cylinders. This is okay if it's an intermediate step, say if you're adding a connective bridge between them later, but submitting any parts with multiple solid bodies will end up costing points on assignments and on exams. Whenever you have multiple solid bodies, a good way to determine where the split happens is to go to the drop-down next to the solid bodies folder, and then highlight each of the different bodies. This will show us where the split has happened, and occasionally the names give us a hint as to which feature caused the split. Anyway, where do we want to go from here? Let's add another shape coming off of the peg we've just created. However, the peg is cylindrical, so we can't sketch on it. We're going to have to be clever here. Let's draw our sketch on this front surface of the brick, and then we can extrude to start at the cylinder instead of the sketch plane. In order to do this, I'm going to open up a new sketch on this front surface, But this time, we're going to use the polygon tool to draw us a hexagon. As you can see, we can sketch outside of the bounds of the surface that we selected as our sketch surface. SolidWorks interprets all surfaces and planes as infinite, meaning that we can sketch wherever we'd like along this 2D plane. I generally like to produce my sketches out in space and then use my relations and dimensions to define them. This lowers the chance of accidentally creating geometric relations that I didn't intend for. So, to define this sketch, I want it centered, so we can use a vertical relation between the midpoint and our origin to pop it into the correct position. We can then define our hexagon as having a side-to-side distance of 15 units by using our Smart Dimension tool there. And then we can align it so that the top point is vertical with our center point, locking its rotation. Finally, we can dimension this bottom point here to be 40 units up from our origin to fully define our sketch. Now that we're done with that, we can go back up to our Features tab, select Extruded Boss Base, and take a quick look at what it is that we've got. This time, instead of using the Sketch Plane as our From option, we're going to select the Surface Face Plane instead. For this, we're going to need to choose a surface, so I'm going to select the cylinder, and we can see that we get some strange things happening at the other end of our extrude. Whenever you use Surface Face Plane as your starting condition, SolidWorks makes the end of the extrude match the curvature and orientation of the starting surface, which gives us this interesting effect. In this case, though, I don't really want that curvature, so let's explore some of our other options. In this case, instead of starting our extrude at the peg, we're going to end it there. In order to do this, we can change our from surface face plane back to sketch plane, and then change our direction 1 from blind to up to surface. From here, we select the surface that we want to act as our terminating surface to set the extrude to go up until it hits our peg. Another option that we have is instead of up to surface, we can use up to next. Up to next continues until the extrude has reached a surface that fully blocks the extrude path, while up to surface requires user input. In this case, they're effectively the same option, but up to next can get you there a little bit faster. One other option that we can show off with this extrude is instead of having the starting condition set to sketch plane, we can set it to offset. This is going to work similarly to having the offset end condition, but in this case we're changing where the extrude starts instead of where it ends. I'm going to set it to have an offset of 5 units, and we're going to reverse the direction so that it starts a little bit closer to our initial peg. The next bit of extrude that I would like to cover is the draft option. This option allows us to have our extrude expand or shrink as it continues, and can be activated by selecting this button. As you can see, increasing the draft angle is going to make it so that our extrude shrinks faster and faster as it approaches its end condition. However, we can flip this around by checking the draft outwards box. This is going to make the profile grow instead of shrinking. Do be careful though, as if the draft angle is too high, then the cylinder is no longer going to fully block the path of the extrude, breaking our end condition. One other interesting thing that can be done with drafts comes into play when we activate Direction 2. Checking the Direction 2 box allows us to reuse the same sketch and starting conditions to create another extrude going in the opposite direction. We can choose new end conditions for this extrude, and we can also change the draft information. Direction 2 can also be used without having the draft active. You can deactivate the draft option by once again selecting the draft button. Now that we've got all of that sorted, we can hit our green checkbox to finalize our extrude and take a look at what it is that we've made. Well, the end result isn't as valuable as the things that we've learned along the way. However, while we're here, let's show off some additional sketch tools. First off, I want to show off Convert to Entities. This tool allows you to copy something from your model onto the current sketch plane. As an example, let's open a new sketch on this surface here. Now that we have that, let's select this front surface and select Convert Entities, and we can see that it copies the shape up into our current sketch. With Convert Entities selected, we can also bring over individual edges, such as this one here. One of my favorite features of Convert Entities is that you can use it to project an entire sketch onto the current sketch plane. You can do this by selecting the sketch from the design tree. You may need to reveal it by hitting the drop-down next to its feature, and then selecting the sketch. From here we can select the Convert Entities option, and it will pop the entire thing into the current sketch plane. Another useful sketch tool is Offset Entities, which does exactly as it says on the tin. It allows you to create a new loop or sketch entity based on a given sketch entity and some offset distance. We can change the direction that it's offsetting by hitting the reverse box, and we can change the distance by modifying this numerical value here. Finally, objects are usually made out of some form of material, and SolidWorks allows us to define a material for our model. We can do this by right-clicking on the Materials option in our design tree, and then selecting from the menu here. If you don't see a material that you like, we can select the Edit Material option to bring up SolidWorks' entire material database. There are many benefits to choosing a material for your SolidWorks model, but one of the main ones is that using a material is going to allow us to find the mass of our part if it were to be made of that material. Oftentimes, in your homework assignment, we're going to give you a mass value to compare your model to. This is for your benefit only. We do not grade the models based on the mass. It does, however, allow you to get an idea as to how close your model is to the one that's given in the assignment. You can measure the mass of your model by going to the Evaluate tab up on the ribbon, and then selecting Mass Properties. We can find our mass value here on the pop-up, and we can change the number of significant figures that it gives us by selecting the Options tab and setting it to use custom settings. You're always going to want to make sure that your mass matches the given mass to the given precision. So if we give you the mass at 3 decimal points, make sure that your mass, when set to have 3 decimals of accuracy, matches the one that we give you. Well, that covers about everything that I had to talk about for today. Have a good day, happy modeling, and we will see you again next time.